Now let's consider an interesting case. We have two light bulbs. One is rated at 100 watts and the other one is rated at 60 watts. And we connect them to a EMF source of 220 volts in parallel and then in series. Which one will be brighter in each case? Well, the rating of the power of the light bulbs at 220 volts is the power that they will use when they are connected to 220 volts. So here, both of these light bulbs are connected to 220 volts. So this will use 100 watts of power. This will use 60 watts of power. So this lamp will be brighter than this one. So that is what we would expect naturally. Now let's come to this example. Here, they are connected in series to an EMF source of 220 volts. But note that this time, across each one of these resistors, the voltage, each one of these lamps, the voltage is not 220 volts. To compare their the power they use in this circuit, we can use P is equal to I squared times R. Since both of the lamps will use the same current will run through both of the lamps, the one that has a larger resistance will actually be brighter. Now, how can we determine the resistance? Let's look at this example. The power can also be written as V squared over R, or the resistance is V squared over the power. So you see here that this lamp has a power of 100 watts connected to 220 volts. Whereas this one, so let me just write it over here, the resistance of the 100 watt lamp is actually the voltage squared. In this example, in Turkey is 220 volts squared divided by the power is 100 watts. And the resistance of the 60 watt lamp is 220 volts squared divided by 60 watts. You see that the 60 watt lamp has a higher resistance. This is larger than the resistance of the 100 watt lamp. But since the 60 watt lamp has a higher resistance, when you send the same current through both of these lamps, this lamp, the 60 watt lamp, will be brighter. So here, 60 watt lamp is brighter. In this case, when they are connected in parallel, 100 watt lamp is brighter. Note that in this case, the 100 watt lamp is not using 100 watts. If you want to calculate the total power that the 100 watt lamp is using in this case, you can just calculate the current running through the system. It's 220 volts divided by the total equivalent resistance of the system is 160 watts. This is the current running through the system. And then you can just use the same current and put it over here and determine how much power each one is using in this circuit. So whenever you are interpreting the ratings on a given device, given equipment like the lamps, the power ratings are always correspond to a specific voltage. In Turkey, whenever you read the wattage of a device, it will always correspond to the case when you use that device at 220 volts.